So now in this video I'm going to explain about the subtraction instruction, so which is having SUB. So this is having the function of subtraction register or memory from accumulator. So it means whatever is the content there either in the register or at the memory location, so that value should be subtracted from the accumulator, and after performing this subtraction operation the result should be stored into the accumulator itself. So before going into the more detail about this instruction, that in the previous video already had explained about that 2's complement method to perform the subtraction, which is used by 8085. So before going into this instruction, you must have to go through that videos which I had explained previously. So now as per this instruction, their opcode will be what? Their opcode is SUB and their operand will be 8-bit register or memory. So here we can understand this with the example first. So we will take the example here as like subtract C. So here the function of this instruction is subtract the content of the C register from the accumulator register, and after performing this subtraction operation, store the result into the accumulator itself. So before execution of this instruction, I am taking here the data as accumulator content. I am taking here as a 37H, and this C register content I am taking here as a 40H. So this is the data what I had considered before execution of this instruction. So now how it will perform? That it is going to use that 2's complement method to perform this subtraction operation. So here this is going to subtract the C value from the accumulator here. So what we are going to do first, we have to do that, we have to write this 37H as it is, whatever it is given as a accumulator value here. So this can be written in 8-bit form as a 0, 0, 1, 1, and for the 7 it can be written 0, 4 times, 3 times 1. So now here how to write this C? So this C is having here as a 40H, their binary it will be 0, 1, 0, 0, and this 0 can be written as a 4 times 0. So this is in binary form as a 40H. Now we have to take 2's complement of 40 so that it will become as a representation of minus 40H. So if you take their 2's complement, then how it can be written? This will be 0, 0, 0, 0, 0, 0, and this 1 will be as it is. So after the first non-zero element, the value is 0, so this will be here 1. So this is 1, 1, 0, 0, remaining 4 zeros. It is giving here the representation of minus 40H, which is going to be written here. So this is C value, it is minus 20H representation. So this can be written here as a 1, 1, 0, 0, and then this remaining 4 times 0. So now if we'll add these two, then it is giving the subtraction of A minus C. So here at the first stage 1 plus 0 it will be 1, then again it will be 1, then again it is 1, at the fourth stage it is 0, then again it is here 1, then this stage it is 1, 1, 1, and here this side carry bit is showing here 0. Carry bit it is showing here 0. But what I explained in that 2's complement method subtraction, there I told that after performing this operation internally, microprocessor will make this carry complemented. So here as a final effect on the flags, it is showing here this carry bit will be complemented. So here we need to write complemented carry. So this carry bit will become here 1 with the same result here, whatever it is, 1, 1, 1, 1, 0, 1, 1. So this will be the result with this flag status of carry. Now we will write that remaining of the flags. So here this sign bit, this D7 bit is 1, so their sign bit will be here 1, and this result is non-zero, so 0 flag will be 0. After then you will see that this auxiliary carry has not generated from this stage, so that is the reason this will be auxiliary carry will be 0. And if we'll count here this parity bit, so parity bit means in this result it is showing here 7 number of ones, so here it is odd parity, so parity bit will be 0 here, and carry flag should be 1, because while doing this operation we had seen it was 0, but as a final effect upon this carry as per the provision whatever it has made in 2's complement subtraction method, so here if their MSB bit is 1, it is showing that this result is in negative. This result is in negative, it means it is already in the 2's complement form, so this complement also should, this carry should be also complemented, so here it is showing this 0 is becoming here as a 1. So finally this carry bit will be 1 here. So this is the effect of the flags, effect over the flags after execution of this instruction. So here this whatever we got F7H, so this will be stored into the accumulator. So after what will be the content? This accumulator content will be F7H, and there is no effect upon this content of the C register. So C register will have the same as a 40H, and flag registers will be updated with these values. So this will be the result after execution of this instruction. Now we will talk about their size in byte. So as per the explanation given earlier, this instruction contains only English alphabet, so that their size will be considered, or their size will be only 1 byte, and their machine cycle also will be 1 only, because these all the operations is happening inside the processor, so it is accessing only once about this opcode from the memory. So this processor is accessing memory only one time, so that is the reason that operation is called as opcode fetch operation. So their machine cycle will be 1 only, and that operation is called as opcode fetch, and their T states will be 4 by default for this opcode fetch operation. If it is memory, as like whatever I can write it here as a SUB 2050H. If I am taking this as an example with this, no, we will take it here. This is as a operand, we have to consider this SUBM. So here this memory is the operand, and this memory, what I am trying to say that this is HL content. So here this 2050H will act here as a memory location. So for example, if this is the memory organization, and here at this 2050H, if the values it has stored as a 40H, and whatever we will perform the operation, it will be similar to this whatever we had learned here. So the result will be same, only here as a size of this instruction is a sub M, it is having only English alphabet, so their size will be only 1 byte. Only the machine cycle it will differ here, because 1 by default will be opcode fetch, and second time it has to read this operand here, which is pointed by this HL register pair with the values of as a 2050H. So sub M means subtract the content of memory which is pointed by the content of the HL register pair. So before execution of this instruction, if the HL content is 2050H, so that will be put upon this address line, and through the address line it can fetch the values from this memory. So at this address in the memory, the value stored is 40H, which will come inside the processor. So that is called the second machine cycle here, and after taking this value, this will not change anything at 2050H. It will just pass that 40H inside the processor. So that 40H will be subtracted from the content of this accumulator, as I had taken here as a 37H. So this A is 37H. So it will subtract this 40h from this 37h in the similar fashion whatever I had explained here, and after performing this subtraction, result will be stored in the similar fashion into the accumulator without making any change in the content of this location. Whatever we have it as a 2050h, it is 40h, so it will be as it is. So we had seen first machine cycle, it is called opcode fetch machine cycle, and second one is how it readed this data from this memory, so that is called the second machine cycle. So total it will have two machine cycle, one is called as a opcode fetch and second one is called as a memory read. As I told, after performing the subtraction operation, result will be stored into the accumulator itself as like this, and this memory location content is not going to change, and this flag will be affected in this fashion itself. So here by default this 4 plus 3, 4 for the opcode fetch and 3 for the memory read, it will take total t state as a 7 t state. And here in the note we should write that how the flags will be affected. So we can say that all the flags are modified. All the flags are modified to reflect this result whatever we have. So as a result of this subtraction, what are the effect it is going on the flag, so all the flags are modified as per the result obtained here. So this is the note whatever I had given, and by this way I hope you understand this subtraction instruction and how it is making the effect over the flags and how the result is stored. These all the things you have learned with much of clarity.